Let's consider it again. For the same problem, if we do not want to separate the linear ones and nonlinear ones, we can all write the two. We can all write the two equilities in one function like this, and we can get a renewed function like this, a constant function like this. So these are the two lines to calculate the equalities, and still the inequalities will equal to n dimensions. And if we include all the constraints in this function, we do not have to specify A equal and B equal again. So we can assign now to x dimensions because we have already expressed this earlier in the function. So now we can solve the problem with S-mean CON function and get the result. We should get the correct result, and using these two methods, the time required might be similar. So any problems on this part? So now let's summarize the minimization problems. There are certain limitations in conventional, the previous I called it conventional optimization problems. The biggest problem now is we call it a local minimum. Because we have to specify the initial searching point first. If we have an objective function like this, if you cannot specify the initial searching point, for instance, if you select the initial searching point, it will get a result like this, and the problem will restart. And still the flag returned might still be larger than 0. You can see the optimization is successful. But actually, it will not be, because this one could be considered as a local minimum point. However, this one should be a global minimum point. However, to find the global minimum point, it is not an easy task. You must select a good initial search point. Otherwise, you may lead the program may lead you to a local minimum point if you are not able to find it. So this is the biggest problem in conventional optimization problem. How can we solve this kind of problem? How can we avoid local minimum? It should be said that today there isn't any universal way to solve this kind of problem. There isn't a method which is said to guarantee a global minimum. So there isn't any method. So what we need to do is one is to select a few initial points and perform optimization and see which one gives the smallest objective function. This is one way. The other way is to use evolution-based methods, such as genetic algorithms and partial swarm optimization problem. And I will talk about this one later on in chapter 10. So up to now, we have still used these pure search points. From the initial point, we have to search the optimization. We have to find the optimum point from the initial searching point. So there might be some problems. So up to now, we have to select several initial points and see whether we can get consistent results. And later on, I shall talk about evolution-based algorithms. So there are certain limitations here.